Hello and welcome to MLOps Minutes. So in this very important episode, I'm going to demystify TDD, or test-driven development. Data science is a dream boulevard for doing TDD and saving an enormous amount of time. But quite often, I come across a lot of developers who get their brains in knots and really get their feet stuck in the carpet when it comes to implementing this method. And that's what this episode is all about, explaining how not to do it. So at the end of the previous episodes, we set up our first unit test. And that really is the top of the mountain. That's what we're aiming for. But to reach the top of the mountain, you have to take lots of small steps. The first of these small steps, the most important, is to set the test, i.e. in TDD, you ask yourself the question, what do I want to do? The idea is that before you even write a single line of code, you'll have a single implementation ready for production. We're going to ask ourselves, really, what do I want to do? I often come across developers in the process of developing who are a bit stuck, and I ask them, what do you want to do? And quite often they're unable to describe the problem in language. And as long as you can't describe the problem in language, it's very difficult to implement the solution. TDD is there to help you. The idea is to write a test first, before even writing the implementation you want. To write this test, I'm going to zoom in a little. In general, what I do is in my code, I put little comments, like this given. Basically in one, I'm going to have my input parameters, so what do I have as input? In two, I'll run my code, my production implementation. And in three, I'm going to say to myself, what do I expect as output? What do I expect as output from my algorithm? For this demo, on the input side, we'll say we have two data frames, one on the right and one on the left. On the output side, we'll say that we're doing an expected data frame. We'll resume the previous data frame. And what we want to do is test the output of a production algorithm. We'll do data frame result. For the moment, we're not going to write the code, and we'll want to test that we have equality. Panda.testing. Assert that our data frame from our algorithm matches our expected data frame. Now I know how to pose the problem. I know that I have two input data frames and that I expect an output data frame of this shape. Now I can run my test. Yes, it's not going to work, but my first step of telling myself what I want is answered, and that's the key to the whole thing. Second step, now it's time to start making an implementation, and that's where a lot of people get their brains in a knot. The idea is that you don't have to make clean code right away. You can really code dirty, i.e. go as fast as possible, no functions, no classes, just what's needed to make our tests green. We may even refine, correct inputs and outputs, no big deal. The idea is to iterate as quickly as possible so that our tests turn green. That's what I'm going to do. It's not very complicated. I'll run the test and it'll turn green. There are cases where a lot of people get their feet stuck in the carpet. What happens is that often you might call a database, maybe you're going to call web services, it's all the same. What happens is that it's called test-driven development and not test unit-driven development. In other words, you can't make mocks right away. The mocks are at the end. In other words, when you're developing, you're actually going to call the database. You'll call your web services. This will enable you to find out what's really being returned and to be able to iterate extremely quickly. That's the point, to iterate very quickly. And you'll be able to refine the code as you go along. Once you've got your code up and running, calling your database and web services, you can start cleaning up your code. That means implementing clean code, making classes and beautiful functions. And finally, once your code is pretty clean, you'll be able to start mocking your calls so that your tests become truly unitary. And the advantage of setting up unit tests, i.e. tests that no longer call your web services or your database, is that you can play them automatically in your continuous integration. For example, on GitHub Action, every time you push a commit, your unit tests will run. This gives you very quick feedback on whether or not you've broken anything in the existing code, and that saves an enormous amount of time. So now that, if there's one piece of advice I can give you that will really save you time, it's that in life, one, first make it work. Make it works, i.e. do something that works, no matter how it's done, no matter if it's clean or not, do something that works. Once it works, make it clean. In other words, once it works, you can iterate and refactor it so that it becomes very clean code. Once your code is clean and very simple, if you need to, you can make it fast. In other words, if you're having problems with slowness, you can optimize it to make it very fast. In general, clean, simple code can be highly optimized very simply. Never give yourself a brainwave, get straight to the point. So, can everything be done in TDD? No, there may be cases. Typically, this happens a lot when I'm doing front-end development. What happens is that sometimes I have such complex cases with workflows that I don't master. I don't know what I want. I'm unable to know what I want. And so I have to do some exploratory work to finally understand the need and know what I want. I can't develop in TDD because I don't know what I want. On the front end, we generally do storybook-driven development, another technique not related to data science. I'll finish with the theory, the part that's a bit more boring. TDD is based on 3 laws. The first law is that you can't write production code until you've written a unit test that fails. The second law, you can't write more test code than it takes for a unit test to fail. And not compiling is the same as failing. Typically, I could have left none out. That means my test didn't work. I could have started coding my implementation straight away. You can't write any more production code than is necessary for the currently failed unit test to succeed. The idea is to make code only to meet requirements and not to make more code than necessary. Thank you and see you soon for more videos.